Hello everyone, once again to lecture 2, that is de-arsenic galvanometer. Its construction is more similar to ballistic galvanometer, having some mirrors, and where in the ballistic galvanometer, as we see, we have to find out the number of charges passing through the coil, which is due to the magnetic flux in it. Now, in a de-arsenic motor, we also same thing. We will do the theory part, principal operation, constructions. Now, in this, galvanometer is basically, as you know, it is an electromechanical instrument which is used for detection of electrical current through a circuit. As thing, as you know, in the previous also that the charges of charge sensitivity is 2 by t time of a basically current sensitivity. So sensitivity of a ballistic galvanometer is very low. So this galvanometer cannot be used for measurement of heavy current. So this in this galvanometer, which used as an activator for producing the rotated deflection, we will use the D arsenal. It is very more sensitive and very much useful as an instrument where we develop various type of instrument for a like range communication as a translation telegraph cables also. So, regarding the basic of de-arsenal principle, it is very same as an exact replica of your ballistic galvanometer, where you having some moving coil fixed placed in a permanent magnetic coil. Whenever the moving coil carrying some current, there should be some torque providing due to the interaction of current and the magnetic field due to the permanent magnet given by Lorentz force NBI. This providing movement in this particularly moving coil and give some deflection which can be used using the mirror or a deflection indicator principle also. Okay, they also basically it is a DC meter. Okay, which is known as D. First D means DC meter movement is known as D also meter movement because it is first employed by one of the French sciences that is called D Arsenal in making the electrical measurement. This, as you know, this is a basic meter movement is a current measuring device. In a previous, they measure the charges also, but this meter resolve the purpose of how we use the base of a meter voltmeter is a ohm meter. Here we use the basic principle of measurement for ammeter and voltmeter most of the instrumentation. Where the ohm meter is basically current measuring instrument. By using the voltage and current, we use the DC resistance in the circuit also. Okay. Now, containing part of a de-Armstrong galvanometer, it is the same aspect of ballistic. We contain a mirror which will be ring upon a particularly moving structure containing upper suspension and lower suspension. And this upper and lower suspension carry the current I that will also be carried by basically the moving coil. So, as we know, the whenever the spring carrying some current, so this overall instrument is have the very less characteristic to carry the current. So in the more or less we have to be increase this range by using some range extension meter. This diacetyl meter which having some upper suspension lower suspension have between some moving coil which is wrapped over a iron core which is aluminum former more usually placed between some north and south pole. As you know, we also be we will describe in detail where we see having some moving coil. It is a basically current carrying element having some rectangular or can be sometimes it should be circular shape depending how much area should be used. It should suspended between some free or turn carrying vertical axis of symmetry. This particular moving coil meter is arranged between some permanent magnets around the iron core elements. This iron core is spherical in this R particular case is circular but cylindrical is in coil cylindrical if the coil is rectangular both case. Okay, if iron core is spherical in shape, if coil is circular for which you will bound over it. Okay, if this is cylindrical, iron core is cylindrical, if coil is rectangular. So in both the cases we want a low reluctance path for system, so more stronger field will be used by this particular coil and given the more deflection torque and also the sensitivity of the galvanometer should be increased. Now talking about the damping system, damping is heavily required as you suggested below also. Damping is required, damping torque is required because the we require the particularly indication in a very small portion of time. If damping is very large or a uh, oscillation over a true value is very large for a large time, then the timing or a timing should be great. So we'll reduce by using some damping torque. In this particular case, we will use the eddy current damping using some metal former parts also. This particular damping is obtained by connecting a particular small resistance across the galvanometer, and this damping, depending upon the resistance, can be obtained as a this particular damping give across the critical damping area adjusted by some resistance values. Suspension as a upper and lower suspension, it acts as a spring contention. This spring can be used of a gold or copper wire having this very small resistance, having small uh, uh, diameter upon approximately 0.12 to 0.05 mm diameters, and firmly over the ribbon suspension. This is called upper and lower suspension. And most importantly, as I said, this particular suspension carries some current, due to which overall the current range of the system out is very low. Indication for purposes, we use a small mirror ramp, which is beam of a light casted on a system also, and a zero setting, which will provided the coil to be resetted after the deflection. Okay, this is a overall scenario. We will talking about d also parameter, and in this working is more similar toward the your toward the galvanometer part. We will use using the ballistic galvanometer. In the particular part of working, we will continue in next lecture. Thank you so much.